Okay, so now that we've spent some time looking at things in this special case of the open set category on a topological space X, it's time to do things more generally. So eventually we want to define sites, and we want to define the category of sheaves on a site. And the first stopping point, just as it was in the case of the open set category, is to define what sieves are. So we gave a special case of this definition before, and now we're going to give the general definition. And again, we're going to do it both in the internal perspective and the external perspective, just like we did with the open set category on a topological space. Okay, so let's let C be a category. An internal sieve on an object X of C is a collection S of arrows with codomain X. So that means arrows going from something omega say into X. Saying that the codomain is X just means that the tip of the arrow is pointing into X. So an internal sieve is a collection of such arrows. It's a collection of arrows with codomain X such that maybe B into A into X is in S if A into X is. So what I mean by this is that if I have an arrow F and G, I call this F, that if F is inside of S and G of F is defined, then G of F is inside of the sieve. And so just as before, this is a kind of downwards closure thing. We're saying that we've got some set A going into X, and maybe we have a bunch of other sets, A prime, A prime prime, A double prime, and we have maps from these guys sort of running around in some chain like this. And as soon as this original morphism is inside of the sieve, so is this composition, and so is this composition, and so is this composition. As soon as we put this into the sieve, we also put everything going into the sieve. Okay, so that's the definition of an internal sieve. An external sieve on X inside of C is a subobject of H of X, which is equal to HOM in C, codomain X, in C hat, which is equal to HOM in the category of cats, the category of categories, from C op into sets. So this is the category of contravariant functors. From C into sets. So that's what an external sieve is. And again, this is very similar to the definition we gave in the special case of the open set category. And just as before, it's the case that internal sieves and external sieves are secretly kind of the same thing. They're just two ways of expressing the same data. So I think I made a detailed video in the special case of the open set category kind of showing this, and that proof totally generalizes. So exactly what I said in that detailed video sort of goes through here. Alright, so in the next video we'll start using sieves to define a Grothendieck topology, and thus we'll define sites.